Alright, what's up guys? I am super excited to show you some inverse kinematic legs today with some sprite stacking techniques, and it's just an easy way to animate legs and mix it with your little sprite stacks. So I've got right here, it's just a basic. There's 1, 2, 3, 4 frames of just black, 4 frames of some eyeballs. Actually, I'm going to add 4 more too, just for sake of consistency. So 8 frames of just black square, 4 frames, some eyeballs, and then 4 more frames for the top of his head. So that's just like a little box head, robot head. That's the only sprite I got, and then I've got a little room, nothing special, nothing going on in there. But yeah, so this is inspired by SizeDick. He's the creator of Nomad, and he's got an awesome asset that basically does the same thing but 10 times better than my version. This is kind of brute forced and it's not perfect. The legs don't look nearly as good as his, especially like when strafing and all that. But it does get the job done, and the gist is there. So without further ado, let's just jump right into it. So let's create object player. All right, create an object, and in the create event, we got to set up a good amount of variables here. So we're going to set up our move is equal to 0. So this is going to be for the right leg. We also need to set up, before we start setting up the legs, let's set up a thigh length. So that's going to be, we're going to set that to 12, and then a calf length, and we're going to set that to 16. That sounds good. So a thigh length, calf length, just for the legs. And then, so let's set up right leg variables. So we're going to have an R move variable, set that to 0. Then we need to make a hip. Our hip x is equal to x. Our hip y is equal to y. Our knee x is equal to x. Our knee y is equal to y. Our foot x is equal to x. Our foot y is equal to y. So now that we got those variables, we got a hip, basically a hip joint, a knee joint, and a foot joint. We need to set up our left leg. So copy and paste all that. Type in left leg variables there, and then we're just going to change all these R's to an L instead. So L hip X, L knee X, and then L foot X. Boom. Cool. Save that. Alrighty. Now with our variables set up, let's just go and create a step event, and we're just going to set up a couple of movement variables just so we can move around and see how it's all looking. So we're going to say variable hors equal to keyboard check ord D minus keyboard check ord A, and then var is equal to keyboard check ord S minus keyboard check ord W. And then we're just going to set our H speed. I'm just going to use H speed for this. I'm going to lerp our H speed to our hor times, let's move him like 4 pixels, or 4 pixels a frame or whatever. Yeah. And then V speed lerp V speed ver times 4 by 0.3. Found 0.3 is a pretty good friction. Okay, so we need to set up a variable called var. Actually, let's go to the create event and write down here look direction. We're just going to create look direction variable, and we're going to set that to 0. Okay, so we're going to say look direction is equal to point direction x, y, mouse x, mouse y. Alright, so first thing we need to set up is if our speed is greater than 0.1, we're going to make the legs move. Else, if it's not, then we're going to make the legs stop. Make legs stop moving and make legs move. Cool. Alrighty. So there is a lot of math involved with this, but basically the idea, the gist is we have a hip joint, and then from the hip joint we want to create a knee joint that basically rotates and oscillates around, right? So first thing we need to do is, to get this started anyway, is let's set up a variable called move spud, and we're just going to set that to 2. And we're going to say our move is plus equal to move spud, and L move is plus equal to move spud. Oh god, if I could spell move spud. There we go. Alright, so yeah, we got our R move. Oh, another thing we need to do in this create event here is set the L move to 90 instead of 0. So that way it's offset by 90 degrees, because we're going to be using a lot of sine, cosine functions. So that way that the left leg will move the opposite of the right leg. But most of this we're going to be able to, once we get one leg done, then we'll just be able to easily copy and paste for the left leg. So we got those set up, and then if we're moving, we're just going to add to our R move and our L move. All right, right leg. So first we're going to set up the knee. We're going to say R knee X is equal to R hip X, because we're going to come out from the hip, plus length direction, length dir X. We're going to use the cosine of R move divided by 10 times our thigh length. And then we're going to set that to the direction, so the actual direction that we're moving, direction we're facing. And we're going to say R knee Y, R hip Y plus length dir Y, cosine R move divided by 10 times thigh length direction. Same thing, but we're going to add the thigh length to the end of that. So that way our knee is always below our hip. So it's always facing downwards, right? Oh, I'm setting up the wrong thing. I'm setting up the knees. Yeah, I need to, well, I'm not setting up the wrong thing, but I got ahead of myself. Okay, we need to set up the hips real quick first, because we don't even have our hips set up. So let's set up the hips real quick. So I'm going to create a variable called hip offset, 4. So that's how far from our X each hip is going to be. So you can always change that to whatever if you want wider hips, but so we're going to say our hip X is equal to X plus length dir X, hip offset look direction plus 90. It's kind of the same concept when doing the 3D. Is 0 is always to the right, but we want, if we're pointing to the right, then we want our hip to move adding 90 degrees to that. So that way it's actually pointed to the right. So then our hip Y, Y is equal to Y plus length dir Y, hip offset, look direction plus 90. Okay. And we can easily just set up the left hip the exact same way. So just copy all that and paste that, change these little R's to L's instead. And then after you change the R's to L's, subtract that amount, and that'll be the left hip. Okay, cool. So now back to where I was. All right, the right leg. So this is what we're on. All right. So we've got the knee set up pretty well, but we need to also clamp the knee. So our knee Y, we need to clamp the Y so that's always below our hip. We'll say clamp, or clamp it to where it's not always below our hip, but it can't move farther than the thigh length, basically. So we're going to say our knee Y, Y minus our thigh length, Y plus our thigh length. All right, cool. That's all we need to do for the knee, and then we need to set up the foot. So the foot, in the same fashion that how we had the knee extending from the hip, we're going to extend we're going to extend the foot from the knee. So we're going to say our foot X is equal to our knee X plus length dir X. We're going to do an absolute value though, because we don't want it to go into negative or just look like his knee is inverted because the foot's going too far the other direction. So we're gonna subtract it actually from our knee x instead of adding it. So minus the absolute value of the cosine of our move divided by 10 times our calf length, and we're going to set that to our look direction instead of our regular direction. And then for the our foot y, our knee y plus length dir y, so we're not going to subtract this one. And let me put some brackets here. Length dir y cosine our move divided by 10 times the calf length look direction plus our sine our move divided by 10 times the calf length divided by 2 plus calf length divided by 2. Okay. Extend this out so you can actually see what's going on here. I'm going to make this big. Okay. Okay, so the foot is going from our knee of the cosine of the right movement, and we're going to multiply that, so it needs to move by our calf length towards our directional movement, but we also want to add the sine of our move to it as well, so that way it adds, it gives it this, I don't know what the right word is, but flop to it. It gives it to where it's not so stiff. It makes it to where the knee actually jerks, or the foot is jerking behind the knee, by using the sine instead. And then, yeah, multiplying that by our calf length divided by 2, and then adding calf length divided by 2. Okay, and then we need to clamp it as well. Same thing we did with the knee. So our foot is clamp our foot y to y minus, and we're going to say thigh length plus our calf length, because that's the total distance it can be. That's the total distance of the leg, rather. The total length of the leg, total distance it can be from our y position. And then y plus thigh length plus calf length. All right. Is that all set up? Good. No errors. Perfect. So now what we need to do, copy this. Copy all this from the right leg, and we're just going to paste it and put it for the left leg. And the only thing you need to do is just change all of these R's to L's instead. So I'm just going to go through and change all of these to L's instead. So the hip, knee, foot. I'll start back up here. L move. Thigh length's fine. R knee, L knee. Then L move. Calf length, all that's fine. Then L move right there. Okay. Cool. Make sure you get these little L moves for sure. Okay. And then you can always Control F and just type in R underscore. And besides right here, the length dir, if you see anything in there, just make sure to change it. Okay, so that's all we need to do to make the legs move. Now we need to, if we're not moving, then we want to make the legs all lerp. And procedurally, it's procedural animation, but basically lerp back to a standing position instead. So we're going to say var lerp spud 0.3. I just like 0.3. I think it's a good value a good lerping value for quick, but still see it, you know. I'm going to say r knee x is equal to lerp r knee x to our hip x, right? Because we're going to a standing position by lerp spud. And then r knee y lerp r knee y, our hip y lerp spud. And then we need to do the same thing for the foot. Our foot x lerp our foot x, but instead of lerping it to our hip, we're going to lerp it to our knee x by lerp spud, and then our foot y lerp our foot y, our knee y lerp spud. Okay. Now, the only thing we need to add to this is on these Y values, we actually want to, on the knee, we want to add that we want to be below the hip by our thigh length. And then on the foot, we want to be below our knee by the calf length. So on our knee Y, you'll lerp it to our hip Y plus the thigh length, and then our foot Y, lerp it to our knee Y plus the calf length. Then we just need to copy and paste all that, and the same thing we did up top, but change by just changing everything to L's. So easy enough. Just go through, change all of these little R's to L's instead. And boom. Alrighty, we're almost done, guys. And you'll see how well this works. So let's go to our draw event. And first thing we need to do is let's set the color. So draw, set color, C black. Then first we're going to draw the right leg. Leg. There we go. This one is the thigh. So we're going to say draw line width, our hip X, our hip Y to our knee X, our knee Y. And I'm just going to set it with a width of 6. And then I'm going to say draw line width, or let me put a comment real quick. This is going to be the calf. Draw line width from our knee X, our knee Y to our foot X, our foot Y, and then we're going to do that by 3. Then we can just copy all this and change this to left leg. And again, notice a trend that we're just changing these R's to L's. So L, 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 L. Alrighty. And then I've got my little robot head here. So I'm going to draw my little robot head. So I'm going to say for var I equals 0. I is less than sprite get number, sprite head, I is plus plus. I'm going to say draw sprite ext, sprite head, I x minus h speed. This is just so I always put minus h speed, v speed if I'm in the draw event, because I'm updating the legs in the step event. So it looks weird and offset if I don't add the h speed and v speed, because I'm drawing directly to my X position in the draw event and not like setting everything in a step event. Hopefully that makes sense. It looks weird without it. You can try it without it and you'll see what I mean. So X minus H speed, Y minus V speed, and then I'm gonna subtract. Actually, you know what? I'm gonna add like 4 pixels to that. 1. Oh yeah, and then I got a +4 minus I. Sorry, on the Y there. Sprite Stacking 101, baby. All right, and then rotate. We're gonna rotate it to our look direction, and then image blend, image alpha. Alrighty, so let me finish this comment here. All right, so everything should be set up, ready to go. I'm gonna throw my player in here, and let's see how it looks. I might have to switch the screen over here. Okay, hold on. Let's before I switch it over, I'm gonna move the head up actually a little bit, because you can't really see the legs very well because the head's so big. So we're gonna say V speed, minus V speed minus, let's say minus 8 minus I. Let's do that instead. All right. So hopefully you can actually see the legs. Yeah, you can see the legs. Okay. All right. Let's see. Let's change it to where you can see everything. Boom. All right. Got a little. Oh, did it not change over? There we go. All right. Cool. Now you can see, got a little guy, and then if we move, he runs around. If we go backwards, it looks like the legs go backwards. And yeah, it's not perfect, as you can see. It's not the most perfect thing in the world, but it looks pretty good. hold on, I'm going to move his head up even a little bit more real quick so that way we can really see the legs. And there you go. Now you can see him a little bit better. But that looks pretty good. I mean, like I said, it's not perfect. Like right there, you can kind of see it's like a little wonky. It's far from perfect. If you just move, though, the direction that the player's actually moving, like change all those variables instead of having a look direction, you change those to actual just the direction you're moving. You can't tell. But it's far from perfect. But it looks pretty good. I mean, it's pretty solid. It looks pretty good. Yeah. Here, real quick, I'll show you. Let me go back so you can see. Yeah. Oh, it keeps not wanting to stick to it. There we go. All right. Yeah, if we go into the step event here, and right here where it's got the look direction, if we just change all these look direction ones to just direction, it looks pretty good. It looks better, in my opinion. But if you have, if you're wanting to like have a shooter where you're shooting and you need to point the direction the mouse is or whatever, then it's do it the other way. But yeah, as you can see, this way I got the head, but now the legs will only move the direction that I'm actually moving. So when I'm moving away, it moves away, but my head can still go. So anyway, I hope this oh, you can't even see what I'm doing here. Here we go. Okay. Sorry about that. Here, now you can see it. There we go. See the legs moving in the direction that we're moving. It looks pretty good. Got a little guy's head here. But yeah, so that's just a little tutorial on some procedural animation. And you can see he stops there. Looks pretty good. Especially when you just have the legs move and rotate the direction you're actually rotating. But yeah, that's how you set up a little IK leg system, and how it rotates with the player, and it gives you that fake 3D leg effect that you can add to the bottom of your sprites here. So no longer a need to when doing sprite stacking having like multiple sprites and then switching through them. You can just add some little legs in here now, just like that, and the same principle can apply to arms or anything really. So anyway, I hope this was helpful, guys. I hope y'all enjoyed it, and till next time, peace.